Welcome to Mrs. Neller's notes for her double block algebra class. These are the notes for section 5.3 entitled Writing Linear Equations Given 2 Points. And today we're going to write the slope-intercept form equation of a line that passes through 2 given points. So it's kind of a review of what we've been doing. We're going to start with 2 points, and then we have to find the slope between those 2 points. So that's the extra step that gets added today. And then we're going to substitute the slope and one of the original points into the point-slope form, which we've been working with. And then we're going to solve that equation for y so that it's in slope-intercept form. And we've been working with that as well. So let's review our equations. Remember, our slope equation is going to be m equals y2 minus y1 over x2 minus x1. And remember, those are just the ordered pairs that we're going to be given. And you can label either one of them x1, y1 and x2, y2. Point slope form, that's what we were working with in the previous section. That equation is y minus y1 equals m times x minus x1. So once we find the slope using our formula, we'll substitute it in for the slope. And then the x1 and the y1, that's going to be either one of the ordered pairs that we're going to plug in. And then we'll solve that equation so that it's solved for y, so that it'll be in slope-intercept form, y equals mx plus b. So those are our 3 equations that we're going to really practice and use a lot today. So for example 1, it just says to write in point-slope form the equation of the line that passes through the given points. So we're going to have to do the first 2 steps. We're going to have to use our slope formula to find the slope, and then we're going to use that slope and either one of the points and put it into point-slope form. So I'm going to label my ordered pairs x1, y1, x2, y2, and then I'll substitute that information into my slope formula. So I'll have 5 minus 1 over 2 minus the negative 1 is plus 1. So my slope is going to be 4 over 3. And then I'm going to substitute that slope and either of the ordered pairs into my point slope form. Doesn't matter which ordered pair you use. You can use the negative 1, 1 or the 2, 5. I'm going to use the negative 1, 1 just because I like ones. They're small numbers. Even though this one's negative, it's still just negative 1. Okay, so we'll do y minus y1 equals the slope that we just found times x minus a negative 1 would be plus 1. Okay, the other, if you use the other ordered pair, you would have y minus 5 equals 4/3 times x minus 2. So either one of those would be correct. Now they look different now, but remember if we solved both of them for y, we would end up getting the exact same equation. So let's try that again for part B. You can label your ordered pairs again, x1, y1, x2, y2. We're going to find our slope. So I'll have 4 minus a negative 2 is going to be plus 2. And then negative 6 minus 3. So that's 6 over negative 9. Now we're going to reduce this and we're going to bring the negative up to the numerator. So if I divide them both by 3, I get 2/3. And then if I bring that numerator up to the numerator, or negative up to the numerator, there's my slope. So I'm going to use that and either one of the ordered pairs. Again, let's use the first one. So we could have y minus y1, so that'd be plus 2, equals negative 2/3 times x minus 3. Or if you want to use the other ordered pair, you would have y minus 4 equals negative 2/3 times x plus 6. And again, either one is correct, so there's going to be a lot of different correct answers when you're doing this stage of these types of problems. So that's just practicing those first two steps where we find the slope and put it into point slope form. This next example then is going to take us to the next step where we have to write our answer in slope intercept form. So we're going to start off the same way. We're going to find our slope, x1, y1, and x2, y2. So I'll have 6 minus 3 over 1 minus 4. So that's going to be 3 over negative 3, which will be a negative 1. So that's my slope. And I can use either of the ordered pairs. I'll just use the first one. And I'm going to substitute into point slope form just like we did in the previous example. I'm going to substitute my slope in there as well. Okay, now in the previous example we stopped there. Now I need to keep going. I need to solve for y so that I can get it in slope intercept form. So I'm going to distribute the negative. So I'll have negative 1x plus 4. And then I have to add the 3 over. So I have y equals negative 1x plus 7. So the only difference between example 1 and example 2 is that for example 2, after I write my point slope form, I have to solve for y so that it's in slope intercept form. Okay, for part B, I've got x1, y1, and x2, y2. So I can find my slope. I have negative 5 minus 0 over negative 6 minus 0. Well, that's convenient. That's just going to be negative 5 over negative 6, which will be 5 over 6. Okay, so having this ordered pair 0, 0, that's a nice convenient one when we have to substitute into an equation. Now, I can write my equation in point slope form, and I'm going to pick the ordered pair 0, 0. Let me switch colors here. I'm going to use this ordered pair because that's a really special ordered pair too. I'll talk about it in just a moment. We have y minus 0 equals 5 over 6 times x minus 0. Now, if I distribute, I have y minus 0 equals 5, 6x minus 0. And then if I add that other 0 over, I just get 5, 6x is equal to y. Now, you didn't have to substitute in to point slope form. If you recognize that this ordered pair, 0, 0, that's a y-intercept because the first term is a 0, the x value is a 0, and you have your slope, you could just go right to slope-intercept form because you have the slope and you have a y-intercept. But even if you're not paying attention to that, you can still substitute into the point slope form and then solve for y, and you'll still get the same answer. But if you see some problems like that on your homework where they have you using a y-intercept as one of the ordered pairs, use that shortcut. Okay, last example, example 3. They want us to write the equation of the line in slope-intercept form. Now, there's a couple different ways that you could do this, especially for this first one. This first line, we can find the slope and the intercept. Okay, this point right here is my intercept. That's 0, negative 3. Okay, but I still have to find the slope, so I have to find some other nice, neat points on the line. Remember, that's where the graph grid and the line all intersect at a nice common location. And it looks like, I could mark a bunch of these nice, neat points, but it looks like I'm going down 3 and over 1 every single time to get to these points. So that's going to be my slope. Okay, so I definitely need my slope. So it's negative 3 over 1. And then you could use 2 points. to find the slope, or you could just count rise over run. Okay. Um, and in this one, I definitely have my intercept, so I want to use that as one of my points that I'm going to put into my equation. So if you don't have a nice y-intercept, you'd want to use your point-slope form. Here we do have our intercept that we can read off the graph. So it says write the equation of the line in slope-intercept form. So now that I know my slope and my intercept, I can just go right to that. Y equals negative 3x minus 3. So this skill we've been practicing throughout other sections in the chapter where we're finding 2 points on the line, counting the slope, and then finding the intercept. So that problem, if that seemed like review, that's good. Okay, my next example though, example B, I don't have a clearly marked intercept. But I do have some nice neat points. I have one right there, and it looks like one right there, and maybe one right there. Okay, so it looks like my slope is 1, 2, 3, 4, and over 1. Yep, okay, so my slope is going to be 4 over 1. Now you could use the slope formula too to find that information, or you can just count, as we did. Now this time I don't have my intercept. So I'm just going to have to use a point that I picked here. You can use any of them. I like this one right here because it's the ordered pair 3, 0. And 0 is a really good number to substitute into point slope form. So for this one, I'm going to have to use point slope form first. I can't just go right to slope intercept form. Oops. X minus 3, not 3 minus x. Oops. Okay, let's try this again. I had my y minus y1 equals m times x minus x1. There we go. So now I do have to distribute. So y minus 0 equals 4x minus 12. And then y minus 0 is just y. So y equals 4x minus 12. So I'm reviewing 2 different methods here for how you can work through these types of problems. Okay, if they tell you to write the equation of the line in slope-intercept form, we do have to get to y equals mx plus b, but you just find any 2 points on the line, and you can either count your rise over your run, or you can use your slope formula. And then if one of the points happens to be an intercept, use your slope and your intercept and go right to slope-intercept form. If you don't have an intercept, use your slope and a point and start with point-slope form and then solve it for y so that your answer is in slope-intercept form. So again, this section is reviewing a lot of the steps that we've been working with. Definitely practice these problems. Make sure you show all your work. And if you have any questions, come on in and see me before school.